So let's be careful here. So AKC is 62. AKC is 62. DB is 44. DB is 44. So from there to there is 44. Find the length of AC, which is from here to there, to the nearest integer. So it's an arc length problem, which means it's proportion. So it's the number of degrees of the arc over 360. Well, if this angle, yellow angle, is 62, then that arc is also 62 because central angles are equal to intercepted arcs. The bottom needs to be the circumference, which is 2 pi r. Green is the diameter, so the radius is 22. And again, I always use 2 pi r, so I'd have 2 pi times 22. All right, and what I'm going to do this time is I don't like writing all the decimals out every single time. So I'm going to write 44 pi in here. All right, so 44 pi, because that's what I would get. 2 times 22 is 44. And then I don't know how long the arc is. So I'm going to cross multiply here. And I'm going to stay in terms of pi for this, just because I don't want to keep writing all the decimals. So in terms of pi, I'm just going to do 62 times 44. So 2728 pi. And then I'm going to divide by 360. So now this time, when I divide, because I want to know what the actual decimal number is, I'm going to do the pi in the calculator. So I have 2728 pi. I did not do that right. 2728 pi divided by 360 is 23.806. And it says nearest integer. That means no decimals. So 24 would be the length of that arc. If you don't like doing things in terms of pi, just multiply it out and have your decimal each time. That's completely fine. Just sometimes I think it's easier to not have to continually write out all the decimals.